So namaskar everyone, welcome back to the another video of NumPy, and in this video we will be discussing about the array attributes and the different types of operations on array and functions on NP arrays. So let's get start this video. We have to discuss about the array attributes. For that we need some arrays to practice. So first of all, we have created 1D array by using arange function, and also we have created 2D array by using arange function, and we have reshaped it. If you know, in the last lecture we have discussed about the reshape function also. तो आपको ये सब पता होगा हमने लास्ट लेक्चर के अंदर इसको पढ़ा था and here is we have created arr3 which is three-dimensional array. So basically I will explain the syntax with an presentation. So basic interpretation of this particular code is, first of all, we created an 1D array which consists of 8 elements, and all those 8 elements which starts from the 0 and ends at 7. And on this one-dimensional array, we have applied a reshape function which has attribute 2, comma 2, comma 2. So basically, it means so these three numbers represent our array is a three-dimensional array, and I will explain this with an example which we have already. So here is that example. So basically, we created one-dimensional array from 0 to 7 because we had size 8, and this is one-dimensional array. And on this one-dimensional array, we are applying reshape function. And in reshape function, you can see here there is two, again two, and again two. So basically, this first two represent number of two-dimensional sub-arrays. These two represent. So I will pointing here with arrow. So these two represent number of sub-arrays which has dimension 2. So as you can see here, so this 2 means number of two-dimensional arrays which are basically sub-arrays. So this is as I'm pointing it towards this array. So this is first sub-array and this is second one sub-array. So these middle two represent number of rows in each sub-array. So as you can see here, in this sub-array we have two rows, and these last two represent number of columns in each sub-array. So here you can see there are two columns in this sub-array, and also in this sub-array we have two columns. Similarly, we have np.arange function which consists of 27 elements, and basically we are reshaping it into 3 comma 3 comma 3. So as I told you already, so first of all, this np arange 27 will give an one-dimensional array, and the elements will start from 0 to 26. Basically, this is one-dimensional array. On this one-dimensional array, we are applying reshape of 3 comma 3 comma 3. So these three numbers nothing but our array is three-dimensional array, and the first three represent number of sub arrays which have dimension 2. So here is I am pointing the sub arrays. This is first sub array, second sub array, and this is third one sub array. This middle three element represent number of rows in each sub array. So this is first, second, three, and every sub array there are three rows, and this last three represent number of columns in each sub array. So in every sub array you can see there are three columns. I hope this is clear to you guys, and I will run the code so that you can get the idea how the elements will looks like. Okay, I will run each array one by one so that you can get the idea how arrays will looks like. So I will remove all these and I will print one by one. So ARR1 is one-dimensional array. Now I will print, I will give some space in between two arrays. So spelling mistake, the error is arised due to the spelling mistake. So I will correct it, print. I will give one space here so that we can see arrays very clearly. And now we will print ARR2, which is two-dimensional array having size 3 comma 3. It basically means we have three rows and three columns. So again we will print a space here so that we can see next arrays clearly. So this is three-dimensional array. This is a special array which we have already discussed about it in presentation, PowerPoint presentation. So basically this ARR3 is this array. Now again we will give one space So here is ARR, which consists of three sub-arrays having dimension 2, and every sub-array consists of three rows and three columns. I hope this is clear to you guys. Now we will discuss the attributes of array. Now in the last lecture, we already discussed about the n dimension function. Basically gives you the dimension of array. So basically I will take two examples of it. So np dot ndim. Let's say I want to check the dimension of ARR array. So it's basically three-dimensional array, and this array is nothing but this array. I will check the dimension of ARR2, ndim ARR2. This will give the dimension 2. So as you can see here, dimension is 2. Now we have np.shape function. So basically this function gives the shape of that particular array. Shape is nothing but the number of rows and the columns of that particular array. Let's say I want to check the shape of ARR2 function, ARR2 array. np.shape ARR2. So these three represent number of rows and this one three represent number of columns. np.shape we will apply on ARR, which is basically 3 comma 3 comma 3 dimensional array, which we have discussed already about it. Now we have np.size function. So basically it will give the number of elements in that array. Let's say we have ARR2, which have basically 9 elements. Let's say I don't know how many elements are there. So by using np.size function, we can find out the elements inside the array, number of elements inside the array. So as you can see here, hey, it has given 9 elements. Now we will discuss about the dtype function. If you know, in the last lecture, we have used dtype function to convert the data type of a particular array into the another data type. Now we will use the data type function to find out the data type of array element. Let's say we have ARR2, which have these elements. I want to check the data type of the elements. So for that, I will use dtype function. So ARR2 is the array for which I will run dtype function. So as you can see, the data type of every element inside that array is integer 32. I hope this is clear to you guys. In the last lecture, we have discussed the data type to change the data type of array elements into the different data type. And I know in the last lecture, we have converted the integer data type into complex, strings, boolean, etc. Now we have used to check the data type of the elements. I hope this is clear to you guys. Now we have item size function. So you are getting from the name what it does. So item size function gives the size of that particular array elements into the bytes. So I will show you how. ARR, let's say we will take this time ARR3 array. Now let's say I want to find out the each element take how many bytes. For that I have item size function. I will run this function on ARR3 item size. So as you can see, the value will be in bytes. So you know already one byte, one byte equals to 8 bits. So it means it will be 32 bits size. Now we will discuss about as type function. As type function basically convert the data type of an array into another data type. So let's say we have ARR3 on which let's say we have run a item size function, so it will give the 4 byte, and if we check the d type of it, and if we check the d type of it, it will give integer 32 data type. So basically this is the memory size, you can say, having 32 bits. Let's say I want to change this integer 32 into integer 16. So by using this, we can reduce the memory size efficiently. So for that, I will run as type function as type, and I will use integer 16. So now the as you can see here, the size of has been changed. Now it becomes integer 16. I hope guys these all functions are clear to you. Now we will discuss about the array operations. So first is the scalar operation. Scalar operation is nothing but the we perform an operation on a whole array using just a single element or a number, you can say. I will show you how exactly this will work. So this is, let's say this is, we have array I have taken randomly, and let's say I want to add every array element by 10. So basically I will run this code. I have to add every elements by 10. So now as you can see here, every element will get added by 10. So this is for addition. Similarly, you can perform multiplication operations as well. So it's up to you, whatever the operations you have to run on the particular array by using single digit. To use scalar operation for that. So let's say I want to multiply every element by 2. So I can do this arr 1. So as you can see, every element is get multiplied by 2. Now we also can run comparisonal operators also. So let's say I want to check whether every element is a greater than 3 or not. So for that, I will simply run this code. So this will give me an binary array. Sorry, the name of array is arr1. So every time what is happening here, I will explain you. So NumPy is checking this condition, whether every element inside this array is greater than or 3 or not. So likewise, you can perform comparisonal operators also. Now we will discuss some vector operation. And vector operations basically done on a two arrays. Array should have same dimension. Let's say this is we have array. Randomly I have created these two array and I want to add every consecutive elements. First of all, I will print arr1. So this will looks like this. So here is I am providing space. Now we will print arr2, which is this is the array. Now let's say I want to add every two consecutive elements. Two consecutive elements means this 10 and 1, this 20 and 2, 30 and 3. So every two consecutive, we have to basically apply an operation, and that operation we will define. Let's say we want to add them. So for that we will just add these two array arr1 plus arr2. So the every array will get added with consecutive elements. So I hope the vector operation is clear to you. Similarly, we can perform different types of functions also. Let's say we let's say we want to multiply the every consecutive element. For that, I will run multiplication operation. So you can see here the multiply of this 10 and 1 is 10, 20 and 2 is 40. Likewise, you can run any kind of operation. You can perform comparisonal operators also. So it will give Boolean arrays. So there is a one note. Arithmetic operations or any kind of operations are done when both matrix of a same shape. Hence, every corresponding elements operations yet takes place. So as I explained you already, so the dimension of the array should be same. There are some special conditions on which we can perform all the operations, but we will see in the next lectures or upcoming lectures. So I hope guys this is clear to you. Now we will learn some functions on array. So the first is main, max, sum and product function is there. So basically we can check the minimum element of an array by using main function. So I will show you how. Print np dot main arr. So you can see the minimum element of this array will be 1. Similarly, we can run max also. So the max of array will be 6. Now we can also find out the sum of the all the array elements. So for that we have sum function. We will provide array here. So you can see the addition of all the digits will be 26. Similarly, we have prod function, product function, and this will multiply the every element of the array and will give the final result. So this is the final result. It is basically multiplication of all the digits. Now we will discuss about some statistical functions. So basically statistical functions provide mean, median, standard deviation, and the variance. So we will run all these functions on the same array which we have created here. I will print this first of all. So this is we have array. Let's say I want to find out the mean of this array. Mean is basically average of array elements. So np dot mean, and I will provide the array. So you get the mean here. Similarly, we can find out the median also. Np dot median, and here we will provide array. So as you can see here, it is giving some error because of we did spelling mistake here. Yeah, now it is work. Now, similarly, we can find out the standard deviation. So basically, standard deviation is a statistical function which tells us how the values are away from the main value. Now we will learn standard deviation function, which is std on ARR1. So this will give the standard deviation. Similarly, we can find out the variance of the array elements. So this is the variance. Variance and the standard deviation functions gives the how our value are spread from the main value. I hope the statistical functions are clear to you guys. Now we will discuss about some trigonometric functions. To be honest, in a data science journey, we will use very few trigonometric functions, or a negligible you can say, but still we will discuss about it. So we have ARR array. Now we will run some trigonometric functions. For example, let's say I have to find out the sign of every element, sign value of every element. For that, I will run sign of ARR1. So you can see we got the value of sign of each digit. Similarly, you can find out the value, tan values. So likewise, you can run any kind of trigonometric functions on an array. It will give the that particular trigonometric value. I hope this is also clear to you guys. It is not that much useful in a data science journey. Now we will discuss about dot product. This is one of the important topic. So guys, I will say focus on this so that you can understand easily. So dot product is sum of multiplication of all the respective element of row of first array and the column of second array. So I will show you. So here is we have created A array and B array, which are basically square matrix. And this is A1 and B1 array having different shape. This A1 array has shape 2, 3, and this B1 array has shape 3, 2. We will take one cell here. Okay, so now I will run the dot function on it. So before running this code, I will show you in a presentation how basically this work. So here is you can see there is a condition for a dot product, guys, and condition is number of columns of first matrix. Number of columns of first matrix should be same as number of rows of second matrix. Should be same as number of rows of second matrix. So this is the main condition for a dot product. So this is the dot product. So now we will implement this. So as you can see, the first matrix has number of rows are 2 and number of columns are 2. Even second matrix also have same shape. So easily we can run dot product on this. So for that, we have np dot function, and in which we will provide the array. As you can see, the dot product is this. Now we will find out the dot product on this two matrix. np dot function is there, and we will provide the matrix A1 comma b1. So you can see the dot product will be this. So I hope dot product is also clear to you guys. Now we will find out the log and the exponent of array element. We have same array. So this is array. Now we will find out the log and the exponent values of this array. Here is we have array and we will find out the log value of each digit inside the array. So the log value of np dot log function is there and I will provide the array. So the log value of every element is this, you can see. Similarly, we can find out the exponent values of all the array elements. For that, we have exp function in which we will provide the array. So you will get this exponent values of all the array elements. So I hope this is clear to you guys. Now we have remaining three functions. First one is a round, floor, and ceil function. So we will discuss one by one what exactly they do. First is we have round function. So basically, round off is a function which round off the float values. So I will show you np dot round function is there, and we will provide arr in which. So this basically gives whenever we have the fractional part of this float value is greater than 0.5, we will have next perfect integer value. So here is a value which is greater than 0.5, and that's why it will gives the next perfect integer. Which similarly, here is also greater than 0.5, so it will give 57, and this is also greater than 0.5, so this will give next value, next positive integer, which is 26. And here you can see the value is not greater than 0.5, so that's why it will give 20. Here is also not greater than 0.5, it will give 69. So this is how our round function will work. Now we have floor function. Floor function basically remove the fractional part of float value. So this is the fractional part of this particular value. This is fractional part. So floor will remove all those fractional part np dot floor, and in which we will provide our array. So as you can see, the floor function has removed all the fractional part of numbers. Similarly, we have ceil function. Ceil function basically gives the next perfect integer value. So the next perfect integer value of this will be 10. This will be 57. This will be 26. So likewise, it will give the perfect integer of that float value. So np dot ceil function is there, and we will provide the array in which. So you can see the next perfect integer of this will be 11. This will be 57. So likewise, it will give. So I hope this is clear to you guys. If you have any query regarding all those topics which we have learned today, so you can comment and I will try to explain them in a comment section, or I will try to explain in other videos also. So thank you for watching this video.